Good morning. Mr. Herman here with our third installment in our Solving Quadratics unit. So today we're going to learn another method for solving our quadratic equations. So far we have looked at graphs a little bit, and we've looked at inspection, and we've looked at the quadratic formula. Okay, and so we've focused on standard form so far. We've focused on a very basic form of just x squared equals a number, and we've looked a bit at graphs. So today we're going to look at factored form, another one of our three forms that we have with quadratic equations, and we'll also take a look at graphs. And so that should be review from what we saw earlier this unit, but we're going to review it here as it is one of our primary methods of solving a quadratic equation. So we'll start off by looking at factored form, hopefully jogging our memory on seeing this before. And to recall, we know that this form is going to highlight our x-intercepts. Okay, so we're just going to highlight our x-intercepts. We saw this last semester when we were identifying those x-intercepts, those key features from our factored form. So let's go ahead and do some examples here. So just kind of a throwback from last semester, finding our x-intercepts, we know that each of these groups needs to be equal 0, so we're thinking the opposite value or opposite sign of what we see in the group. So we know that we're going to have x equals -2 and +3. We want to write these as ordered pairs, x comma y. Okay, just as a reminder, we know that y has to equal 0 because those are x-intercepts. Once again over here, we've got x equals 5 and 5. Now, 5 comma 0, it'd be the same point on both. So we only need to write that point once. Okay, it'd be just one x-intercept there. And then our last factored form equation, we have x plus 7 times x minus 2. So we're going to have x equals -7 and +2. So we'll write this as ordered pairs here, -7 comma 0 and 2 comma 0. So far we've just done some review of what we saw last semester with our factored form. Now, when we're solving from factored form, so we're already in this form here, it's x minus m times x minus n, those two groups, we can identify if a solution will be real or complex by looking at the factors. And just a reminder, our factors are these two groups. So we've got x minus 5 and x minus 5. Those are two factors. X plus 7 and x minus 2 are two factors as well. So our rule that we see here is that a quadratic equation will have one real solution when the factor is squared. And then I'm also just put in parentheses repeated. So if we're looking up here in x minus 5 times x minus 5, that factor is repeated. We see it twice. Or we could write that as x minus 5 squared. So we'll see both. Okay, so just want to make sure we have both of those covered. A quadratic equation will have two real solutions when the factors are different. And then a quadratic equation will have two complex solutions when the factors contain I. Okay, now we won't often see factors containing I, particularly if we're going to factor an equation. We won't see I in it because we can't factor it. However, for the sake of what we're doing here and looking at number of solutions, we are going to see some factors with I in them. All right, so we're going to take a look at a few examples here of how many solutions. So if we're looking here, we have x plus 2 times x minus 1. Those are factors. They do not have I in them, and they are different. So we're going to have two real solutions. Now, excuse me, our second example here has I in the two factors, which means that we're going to have complex solutions. Okay, so we look up here at our rules. Factors contain I, so that means two complex solutions. And then our third one here, we have x minus 3 in parentheses squared. So we see that our factor is squared, which tells us we're going to have one real solution. So just the one real solution. And that means that our vertex is going to be on that x-intercept, on the x-axis. All right, so we're going to go ahead and take a look real quick at this method that we're going to use, okay, to solve quadratic equations in factored form. And we're going to call this the zero product property. Okay, so what that means is that if I have two numbers and they multiply to make 0, one of the numbers has to be 0. Okay, so if I have 2 times 0, I know it's going to equal 0. If I have 0 times -3, I know it's going to equal 0. The zero product property says that for an equation that's multiplying to equal 0, one of the two factors has to equal 0. Or if there's more than one factor, at least one factor has to equal 0. Okay, now our key here, there's two things that we have to have. The equation must be in factored form, and it must equal 0. So you'll notice this before. We saw this when we did our quadratic formula, that our equation equaled 0 in standard form. In factored form, it must equal 0. Okay, we always need to make sure we equal 0 because our x-intercepts say that y equals 0. All right, so let's kind of look at this rule a bit more and kind of see what it looks like when we apply it. So in the zero product property, we have x minus m times x minus n. There are two groups, there are two factors, equal 0. So we're in factored form and we equal 0, so we're good to go. We can solve with this property. Now what that means is that I take each of my factors, x minus m and x minus n, and set them equal to 0. So each factor equal to 0. Because if this factor equals 0, it multiplies to make 0. If this factor makes 0, it multiplies to make 0. So we got to check both of them. Now we're going to solve each equation for x, and then we're going to write as an ordered pair. So I'm just going to do x comma 0. Okay, and so we're going to do a few examples. Now, find the zeros of these quadratic equations. Here's a little throwback today to our vocabulary for terms for solutions. We talk about solutions, roots, zeros. This is why we use zeros, the zero product property. Okay, so this term of zeros as a solution name kind of comes from the zero product property. So I've got the same factor. It's twice. I'm only going to have one real solution. Okay, so I'm going to say x minus 3 equals 0. Now it'll throw back to solving one-step equations, plus 3 on each side. X equals 3. I've now done step 2. And then step 3, as an ordered pair, 3 comma 0. Now over here, 3x plus 5 times x minus 7. I have two factors here, so I got to check both of them. So 3x plus 5 equals 0, that's one of them. And then the other factor is x minus 7. Now I need to do a little one-step equation over here. I can add 7 on both sides. And then I get x equals 7. Got a little two-stepper over here. Subtract our 5 on both sides. 3x equals negative 5. Divide by 3 to get x by itself. And then I have to write my ordered pair. So I have negative 5 over 3 comma 0 and 7 comma 0. Okay? Now just as a reminder, we're going to have 0, 1, or 2 real solutions. If we're in factored form, almost every time we're going to have 1 or 2 real solutions. Factored form does not usually have 0 solutions. All right, so there's our factored form. In the zero product property, we're going to go ahead and briefly review solving from graphs. This note section is exactly the same as what we saw in 5.1b, but we're going to review it just so you have it here again. When solving a quadratic equation from a graph, we look for the, hopefully you said x-intercepts. Okay, we talked about that here. Today we call them x-intercepts, zeros, solutions, roots, all those good vocab terms we got to make sure that we know. Now, we're going to look at a few graphs here. And how many solutions does it have, and then what are the solutions? Remember, we're looking for x-intercepts. How many times does it cross the x-axis? So this graph here, we have one real solution because it has one x-intercept, and that point is 0 comma 0. On our second graph here, we've got one x-intercept here, cross the x-axis here. So we have two real solutions. So this is, let's see, negative 1, negative 2, negative 3, comma 0. positive 1, comma 0. And then on our last one here, it does not cross the x-axis. So that means that we have two complex solutions. Okay. And we can't identify what those are. Okay. We do not have that in our toolkit to identify our complex solutions here. Only with quadratic formula. And then another version we're going to learn later this week, can we actually solve and identify what the complex solutions are. Okay, so go ahead and answer the last of the questions in the video, and then go ahead and work on your exit ticket and your homework.